Yeah, so when I say organic, it really is carbon, hydrogen, and oxygen. Okay. Now nitrogen works its way in there pretty often. Okay. Sometimes people say CHON, C-H-O-N, carbon, hydrogen, oxygen, nitrogen. Okay, the CHON elements. Every now and then, if it's getting extra spicy, you'll get a phosphorus or a sulfur in there, but that's pretty rare. Okay. So almost all organic chemistry deals with 4 elements, and that's it. Sounds very simplistic, but there's like a million different shapes you can make with those 4 elements. And by a million, I mean way more than a million. Sorry, I severely underestimated. There's probably billions of molecules that you can make with just those 4 elements. So it sounds limiting at first, but then when you realize how these things get put together, it's quite expansive. So we're going to talk about different types of groups. Okay, the left-hand column is the functional group. Okay, we're going to go through 11-ish, 12-ish. How many I got there? 12, I think, functional groups. And these are just different organic features. Okay, first one we're going to talk about is called alkane. And alkane is just a singly bonded carbon chain. That's it. Okay. A chain of carbons, all singly bonded. Okay. An example of that would be butane. Okay. Now, oftentimes in organic chemistry, there's hydrogens all over the place, but they're not really relevant to the actual chemistry. So organic chemists don't typically draw in hydrogens ever. But they're there. How many bonds does carbon make? 4. So if you look at those carbons on my chain, and if they don't have 4 bonds, that means there's some hidden hydrogens there. Okay? But again, organic chemists don't typically draw in hydrogens at all. So this carbon should have 3 hydrogens, that one should have 2, that one should have 2, that one should have 3. Formula for this is C4H10. But when we draw it out, we kind of just draw the carbons. This is an alkane. It's a chain of single bonded carbons. Pretty exciting. Next, alkene. An alkene is a carbon chain with a double bond. Somewhere, anywhere in the chain. Okay, we'll call this propene. How's my pace? Too fast? How's your mood? That's good. I'll take that. Are we excited to still be in school for a couple more weeks? 2 if you're seniors. Really 3 if you're a junior. Kind of weird to make my speak final speak. Yeah. Yeah, I suppose. I suppose.
Is it mandatory finals or is it actually?
It's kind of mandatory finals.
But that includes like AP finals.
Sort of. Let's see if I get yelled at, then I guess it doesn't exclude it. I'm trying to make it exclusive.
Is it in normal?
Don't you just have them like come in with one thing?
Yeah.
But then you have to really get extra time.
Yeah. Alkyne. Alkane is a singly bonded carbon chain. Alkene involves a double bond. And alkyne triple bond somewhere. Oh, sure. We'll get to that in a second. This gets real spicy real quick, but we're gonna take a slow pace, and by the time we get to Thursday this week, we'll be doing some really funky molecules, but it's very systematic, and it's, like I said, it's kind of fun once you get into it. We just got to build the foundation. So that would be called butine over there. Okay? Don't worry about the name really yet, because that's kind of where we're leading into eventually. Next group is an alcohol group. What you need is an OH group. Somewhere, anywhere. Now, OH in regular chemistry is hydroxide. Okay? In organic chemistry, we need an OH attached to a carbon chain. All right? So for example, like this. There's a bond between the O and the H, obviously. Sorry. Most of the time they just write it like that. This would be called butanol. Okay, I'm using 4 carbons for a lot of my examples. Butanol. So if you see an OH group in organic chemistry, it's an alcohol. So alkane, alkene, alkyne, alcohol. Next, ether. Sounds exciting. This is an oxygen. An oxygen in the middle of the carbon chain. Okay, for example, like that. The oxygen makes 2 bonds and has 2 lone pairs. So it can totally fit in the middle of our carbon chain. This would be called diethyl ether. Again, not that you really care at this point in time, but we're here. And of course, there are jokes involving ethers. There's t-shirts and coffee mugs that have jokes about ethers on them. For example, they would have like a picture of a molecule that's an ether, and then it says, or have a picture of the molecule, and it says, you get organic chemistry or you don't. So ether, you get organic chemistry or you don't. There's more, don't worry. We've only just begun with the bad jokes. Aldehyde. This is a doubly bonded oxygen. At the end of the carbon chain. So you'll notice, as you've noticed already, almost everything starts with a carbon chain, right? Some length of carbons attached to one another. Okay. This would be called propanol. Again, don't worry too much about the name. Not yet, anyway. Ketone. Double bonded oxygen in the middle of the chain. Now, oxygen can only make 2 bonds, right? when I say in the middle of the chain, what I mean is something like this, where instead of it being on the end of the chain, like the previous example, it's in one of the middle two carbons. Okay. This would be called butanone. We need a break. We need a break. Good to go? It'd be nice if the weather was nicer. I'm talking about the weather. No, it's just like not like it's like not May. Like it's like 50 degrees outside. That's kind of lame.
It would trick us into thinking it's going to be really good weather for like a week.
Yeah, like what was that? Like late March, like the last week in March, the first week in April, it was like 70s.
Are you still staying?
Not today. Other days I go below those. So I guess. Thanks. Have a great day. Carboxylic acid.
Oh my gosh.
A double bonded oxygen and an OH at the end of a carbon chain. For example, like that. This is known as ethanoic acid. However, you probably know it by a different name. What is that? HC2H3O2. Acetic acid. Ethanoic acid is acetic acid. Same thing. This is an organic acid, but you've been using it all year. Whether you knew that or not. You know what we got? Ester. This is not an old woman at a nursing home. Or maybe. Okay. An ester is, what do I want to describe this? A single, no, that's not what I want to say. I'm sorry. I'm sorry. Ed teacher. Double bonded O next to a single bonded O in the carbon chain. So it looks like this. Something like that. Okay. Or I've got a double bonded oxygen and a single bonded oxygen in the chain next to each other. That's an ester. This would be called ethyl ethanoate. But I'm not even going to write that. Again, names are irrelevant for a little bit. We'll figure that out in a couple slides. This is an ester. How many more we got? 3. All right. Amine. This is a nitrogen in the carbon chain. Oftentimes, the nitrogen groups include their hydrogens like this, or they get written out like next to it. Okay, as NH2, NH3, whatever it might be. This would be called propylamine. Again, don't worry about the name too much right now, but so a nitrogen anywhere in your carbon chain is called an amine. Amide. Amide, not amide. It looks like it wants to be called amide, but it's amide. Is you don't want an oxygen next to that nitrogen? I can draw the exact same molecule. And then just throw a double bonded oxygen right here. That's called an amide. This would be called propanamide. Not yet. One more. Once we get past these, then it open up. Cyclic molecules. A closed ring of carbon. So instead of having it be a chain, I can close that ring on itself. 4, 5, sure. Something like that. Okay. So instead of the chain just going on with an end on either side, we can have a carbon chain closed and make a cycle or a cyclic molecule. This would be called cyclohexane. You want to talk about other things? There's not much to talk about. There's lots to talk about. I don't know.
How's your son and your daughter? How's that line up?
Oh, my son and Mr. Brandt's daughter? Well, they're besties.
What are your thoughts?
Oh, man.
That's fine. We're 7, so it's not like it's, Yeah, Mr. Brandt's daughter and my son are in the same first grade class. And they've been passing little love notes to me. I told Brand, I'm like, well, looks like we're going to be in-laws.
How'd you find out?
Because my son brings them home.
Oh, really? Did you read them?
Yeah, I mean, like a heart with his name on it. And, like,
Oh my God.
you're my best friend and stuff.
You're my best friend. What's his name?
My son's name is Liam. His what one? I don't know. I don't.
How tall is he?
He's tall. He's like my son's like 4'8".
Now we know why.
And he's
That's
7.
huge. How tall is your?
No, 4 foot. I'm sorry, 4'4". 4'4". I can't do my math. 4'4". 4'4". Yeah. Oh, he's crazy tall. Yeah. He'll be taller than me by the time he's like
So
14.
long ago.
Yeah, he's like right here.
Oh, but.
Almost taller than me. Yeah, he'll blow right by but my wife and I. He'll be taller than us pretty quick. That's good for him though.
What tall are you?
5'6" and a half.
The half is important.
Yes, obviously.
I feel like 6'3" is a good height.
6'3".
That would be like an ideal.
mean, that's kind of tall.
Dude, I would love
I mean, I'd take like 5'8".
5'8"?
Sounds nice.
Interesting.
I feel like though, if you're too tall, then you just have to like grab everyone's stuff. So,
Yeah, I don't have that issue.
like that would, yeah.
Or everybody stares at you.
Right, and then people will always probably say to you.
One time my dad went to China once, and he's 6'5".
Oh,
It was just funny. He said the security cameras followed him when he walked by.
maybe I'll gain like 4 inches.
Huh?
Cool.
Yeah.
Well, he'll grow.
I haven't grown in like a year.
Me either.
My second growth spurt's in there somewhere.
I was 5'6" when I was 16.
See, this is funny though. My best friend's dad was like 5'4", or not 5'8" is like the junior. He's like 16.
Yeah, it happens.
So like,
Yeah,
there's a chance.
it happens. Yeah, I was 5'6" when I was 16.
Oh,
Yeah.
And you grew the
And I have
half.
not grown
So
since.
You grew
there's
the half.
Sure. I mean, I say I have to be funny, but I, yeah. When I got my license, when I was 16, I had 5'6" listed on there,
oh,
and I still have 5'6" listed on my license to this day.
I'm gonna write 6.
Kind of sad.
They don't like check.
No, they don't. I mean, well, if I said I was 6'4", there might be a question.
That would be funny. But do that.
Well, I think they'd get mad at
We'll
us.
see how high you
They get mad at you.
I don't think they would prove that. All right, let's do a little more. When naming organic compounds, you first need to be able to identify which functional groups are present. So the functional groups, when I use that term, I'm talking about any of the 12 things we just went through. Okay? So is it an alkane? Is it an alkene? Is it an alkyne? Is it an alcohol? Is it a carboxylic acid? Is it a ketone? Is it a whatever? Okay, that's the first thing you want to identify is what type of molecule do I have? Then we need to give our chain of carbons a prefix. We're not going to go beyond 10, okay? But we need a prefix for however many carbons are in our molecule. If it's a 1-carbon chain, we call that meth. The prefix meth. And yes, that is where the prefix or where the name of the street drug meth comes from. Okay? Methamphetamine is the full name. The meth in methamphetamine is implying a chain of 1 carbon on that portion of the molecule. That is a different chemical structure. So amphetamines are a classification of, like, it's another functional group basically, but it's like a fancy functional group. I don't even know what it is offhand. Yes.
Have you ever tried that?
No.
He's gonna say yeah.
Yeah. He just, yeah, probably can't.
Why Ken? No. Jeez.
I feel like we didn't know.
Yeah, I don't think I'd be employed here.
Well,
Not for getting caught, but just from a functioning life standpoint. Generally, people that try that aren't doing so hot. So yes, no, I have not,
good.
and I have no intentions of doing so. Yeah, that is good. 2 carbons is F, 3 is pro, 4 is bute, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, and dec.
The second half of them is like normal.
Yeah, I was
The
gonna
first
say,
half is weird.
Yeah,
that's the norm.
is what it is. These are the organic prefixes. Yeah, that just is what it is. Yeah. So what we'll need to do first is identify how many carbons we have in the chain and what the functional group is. Okay, a lot of naming organic molecules is those 2 things. How many carbons I got, and what is the functional. Okay. So with every organic molecule, you always want to identify the largest consecutive chain of carbons. The longest consecutive chain determines which prefix you'll use. Any additional carbons in the molecule will be accounted for differently. For example, we can do C5H12. Okay, there's my chain of 5 carbons. What's the prefix? Pent. What's the functional group? Yeah, this is just an alkane. So we're going to call this pentane. Prefix pent for 5 carbons, ending ane because it's an alkane. So this is pentane. Okay. Now, this isn't always represented in this way. Organic chemists are lazy. They get even lazier than this. Instead of using actual C's, they would draw this as that. Sorry, I have to little curvy. That's pentane in organic chemistry. Each end and each intersection is a carbon.
Oh, I remember that.
So they don't show the hydrogens because that's a pain in the butt, and they're lazy with that. And there's an entire notation in organic chemistry, not even writing carbons. You just make lines and zigzags, and every end of a line and every intersection of 2 lines is a carbon. So this would be 1, 2, 3, 4, 5 carbons. This is a representation of pentane in organic chemistry. Okay? Here are the naming rules, eventually, sorry. One vocab word, isomer. An isomer is basically same formula, different structure. This is a big deal in organic chemistry because when we're only dealing with 4 different elements, it's very easy to have 2 molecules have the exact same formula, but those atoms and molecules, the atoms in the molecule are arranged in different ways. So an isomer is a different arrangement of the same elements. Okay, so if I had, I don't even know an example offhand, but like C4H6O4. Okay, there's more than one way to arrange that set of atoms. There's not just one structure from that formula. And those are called isomers of one another. So sometimes in organic chem, just getting a formula is not enough. You're not going to actually have any clue about how that's organized without a picture. We needed to name a smaller chain of carbons attached to a larger group of carbons. Use the same prefix, but the ending YL. For example, let's say I had this, and I also had another carbon coming off of my chain in the middle. What's the longest consecutive chain of carbons? Without doubling back. 4. What's the prefix for 4? Bute. So this is butane, but I've got another carbon hanging off of it, right? So how do I name this other little feller that's hanging out down here? We'd call it methyl. We add a YL to it. Okay? So this would be called methyl butane. But now here's the next question. Where is that methyl group located, right? Because it could be here, it could be there. It can't be on either of the ends, because if it was on the end, then I would just have 5 carbons in a row, right? So that's just pentane. But how do I know whether the carbon is here or there? But I'm saying by the name. You don't. You don't. We're going to need to account for that later, too.
But, okay, does it matter though? Because if you just kind of upside down,
Sometimes it doesn't matter.
yeah, but sometimes it does.
Sometimes it doesn't.
But in that specific example.
It wouldn't matter then. Yeah. Okay, so here are the basic rules. And as you see my sentence, these are very basic rules for naming organic compounds that include various functional groups. They can get way more complicated than this. And that is absolutely the truth. Organic naming can get just insane. So insane that generally with pharmaceuticals, because a lot of pharmaceutical drugs are organic molecules, with pharmaceuticals, they don't even like use this style of naming anymore because the molecules are so big and so extensive that they have like special names. And they just like give it random trade names, right? as opposed to trying to list all of the order of all of everything, and it's just a mess. But here are some basic rules. For an alkane, use a prefix and slap ane at the end. For an alkene, use the prefix, put ene at the end. For an alkyne, use the prefix, put yne at the end. Easy as that. The other ones get a little more complicated. Alcohol, you would start with ane, drop the e, and use all. So an all is basically what it becomes. Okay, after your prefix. So the example I had was propanol, I think I did. Maybe? Butanol. Okay, starts as butane. I drop the e, replace it with OL. So let's go through and name some. This is the backside of the 3-page thing we got going on. Okay, let's name these. Propane. 3 carbons, gets the prefix prop. It's just an alkane, so we're going to call this propane. That, of course, is what's used in a gas grill. Okay. LP tank stands for liquid propane. You pressurize it so that it turns into a liquid. But yeah, if you use a gas grill at home, if your parents use a gas grill at home, it's propane that you're using, that you're burning. What do you want to call this? Propane. Okay. Propine. I'll handle the first part. You're welcome. This is propanol. That's an alcohol. Carbon chain of 3, OH at the end. Aha, now we've hit the hard spot. Let's go back and look at the rules for this functional group. First off, what functional group is this? This is an ether. Okay? So if I go back to the naming rules for ether, identify the prefixes needed for the number of carbons on either side of your oxygen. Okay, so we're going to name both sides independently. I've got 2 over here, prefix is F. I've got 1 over here, prefix is meth. Okay, let's go back. What's it say? Go in alphabetical order, according to the prefixes. Use YL endings on both of the carbon chains and finish the name with the word ether. For example, butyl-propyl ether. In this case, we have ethyl, methyl, ether. All one word, ethyl, methyl, ether. Okay, make sense? What's the functional group? This is an aldehyde. An aldehyde is when you have a double bonded oxygen at the end of your carbon chain. Our prefix is going to be pro. If you look at the rules, it says propane, drop the E, replace the E with AL. So this turns into propanal. Slightly different representation. What's the functional group? This is a ketone. Double bonded oxygen in the middle of your carbon chain. How do we name a ketone? Start with propane, drop the E, and replace the E with O-N-E. Own. So this turns into propanone. Propanone. Almost done. Still prop, free for everything. We have double bonded oxygen and an OH at the end. Propanoic acid. How do you want to name this one? Propylamine. Yeah, don't be afraid to try. Weird names, right? By the end of this week, you'll be able to actually like read the back of a random product and maybe have a chance of correct pronunciation. If you've ever looked at the back of some of those products, any product, right? If you grab your shampoo bottle and read the back of your shampoo bottle, it's like, huh? Isn't this just like, what? This one? Propanamide. Yeah, that E at the end makes it want to sound like I, but it's not. Weird as that is. Propanamide. Last but not least, this is not very possible, though. The angles here are way too tight. Cyclopropane. This stuff will be crazy reactive because if we're trying to make that tight of angles between three carbons, carbon generally wants to be tetrahedral, right? 90 degrees. What's the angle right here? The interior angle, 60 degrees. I mean, that's really, really straining that bond a ton. So this really doesn't exist. Or if you could get it to exist, it would basically react instantly with something because it's not going to want to hold or maintain those 60-degree bonds. That's all I got. You can hang out for 10, talk about life. We'll pick this up tomorrow with more fun. It gets better, I promise. I know today the worst. This is like the worst day of the week, and then this it picks up. Yeah, well, we need the foundation. That's the hard part.
Right.
It'll pick up. It'll pick up.